Hi Rahul.
Hi, sir.
So you're giving data analysis agent solution demo today.
Yes.
Okay, go ahead.
Uh, so, hello. My name is Rahul Patil. I am a AML engineer based in Mumbai. Today, I am walk through the end-to-end architecture for the AI-driven data analysis agent designed for the robust on-premise deployment. The demo is presented by the me, is Rahul Patil, and this is my LinkedIn ID. And this demo is done through the coaching, coached by the Shanti Kumar. And here is a LinkedIn ID of the sir, and here is the sir's uh, URL for the particular coaching. And so for today, agenda is regarding the how we demo is regarding the uh, how to deploy, build, deploy, and optimize intelligent data agent for enterprise environment. So here is a flow chart. So here we can do data collection, data processing, AI analysis, and insight generation. So here you can see the flow chart of the data and flow chart of this particular project. Now move to the next PPT slide regarding the phase to be performed in this particular use cases. So, sir, phases are first phase is to infrastructure and environment setup. So we have to set up the infrastructure setup, then data ingestion and pipeline. Then third is a vector knowledge base. Fourth is a automate ML pipeline. Fifth is insight generation engine, and sixth is deployment and serving, and seven is monitoring and optimization. So all are these steps are going to be performed in this particular use cases. And here is a pictorial representation of the structure. So our solution is structure in 7 phases. We start with the infrastructure, as I say, then move to the data injection, then vector database knowledge, then automate ML pipeline, and then insight generation, deployment and servicing, and finally monitoring the optimization of the model. So each phase is critical for delivering the scalable and secure intelligent AI agents. So now I move to the next slide. So we lay the foundation of our AI agent. This involves high performance hardware. We require high performance hardware like GPU server and high memory modes. So and along with distributed storage also for this use case. On the server side, we deploy ML flow for model management, ChromaDB as our vector database, and self-hosted large language model for local interface. And for monitoring, we rely on the Prothambus for metrics collection and Grafana for real-time dashboards. And this robust infrastructure ensure our environment is ready to demanding AI workflow. So this is a overall uh, infrastructure environment setup required. So here you can see in pictorial form hardware, what is hardware required. Services we require, as I say, ML flow and ChromaDB and the local LLM. And for monitoring purpose, we can use Grafana or Prothambus for that particular our use cases. So this is a infrastructure environment setup. Now move to the next uh, validation framework and security. Before moving forward, we rigorously validate our infrastructure. Our checklist cover the GPU acceleration. So GPU acceleration, we want to 100%. ML flow and ChromeDB access, LLM interface, storages, and Grafana dashboards. As we can see, most of the uh, most of the uh, workflow means architectures and the ML flow access, ChromaDB API, LLM interface, all are required checklist in 100%. And uh, this validity ensures that production ready and secure foundation for our next phases. So here is a graphical representation of our model, means our use cases, what we going to perform, and what is our requirement. Now, moving to the next slide. Next slide is regarding and here is the overall workflow, flowchart representation. We can say system administration, hardware provision, as we discussed, CPU, high memory nodes, distribution storage. So NVIDIA GPU is required for 64 GB RAM, and the distribution mini IO. And for core services installation, we require ML4 server, Chrome DB, and local LLM for the core services. And for monitoring, we require Grafana and Flowthumbers. So, and here we can see validation test on the basis of hardware provision and core service installation. We validate the test, and then then by here we monitoring the checks, and lastly phase 1 is completed here. So this is the overall outline for the phase 1 for infrastructure and environment setup and validation and security purpose. Then next step is phase 2 is regarding the data injection pipeline. Phase 2 focus on unified data injection, structured data flow through the DACs from distribution processing, followed by validation and storage in data lake by multimodal data, such as I use images, text data. This architecture ensures all data, regardless of type. So data may be image size, data may be text. Efficiently, we can process to the machines through machine learning. So this is a first data injection. Data injection pipeline is a backbone for modern data architecture, enabling the seamless collection and transforming the movement of data from diverse sources. So we can say we get data in the CSV file from the data storage. There we can get the data. After we can get the data from the API also, and then the cloud service also. So from there we can get the data sources. Then there is an injection layer is present here. You can see there is an injection layer. This is where data is first imported into the system, and then injection layer can handle both by the batches or real-time data. And then we perform processing and transformation. Means once the data is injection, data is clean, validate, transform. These include the removing the error, standardize the format, means particular standard structured data we want. So here we standardize our data, then ensuring the quality and consistency of data. So it'll help in the train the model, and there is any duplication present in the data. So we can normalize the data, because there is no biasness present in our data. So we can normalize the data. So according to our business rule, and then store the data. After all the processing is completed, after processing, we data load into a centralized repository such as data lake. We can say data warehouses where we can store our data. And final step is to make data available for the analysis. This data we can analysis, finding the report, and help to the build machine learning model. With the help of that data, we can use to train the model. So this is a data injection pipeline phase. After that, here we can see the here data we can get from CSV format or image. Then here we can see the data we can process, then data cluster, data validation, and process data lake, and then data is ready for the analysis purpose. Here you can left side and right side also, if data is the image or video format. So video frame sampler, clip embedding, generate the embedding of the each image, and the image and videos embedded data we can store in a vector database. And with the help of vector database, we can vectorize media and access the data. It is easy to access vectorized data rather, because it is a convenient to access the vectorized data. Then after this, we move to the next phase, that is a vector knowledge base. In the vector knowledge base, in this page, we build the unified vector knowledge base. Means all the data will store in a vector format. So suppose we have the text data. So we just store the text data or image data in a vector format for the semantic search, or we retrieval for the retrieval purpose, because structure and multi-dimensional data is transformed into the high dimension embedding, and that is the advanced models, and that store in a vector database. It may be FASI or Chrome DB database. Here we store the data in Chrome DB because it is a high performance vector database. It is helpful in the semantic search capability, allows us to retrieve relevant information across the diverse data types. It may be any type. And this is a vector database is a backbone of our the AI driven system, because we convert our data in a vector in a machine readable format, and it is help in the retrieval purpose also. And after storing the embedded data in the vector database, with the help of cosine similarity algorithm like cosine similarity, this indexing enable to fast accurate retrieval information, which is crucial for the semantic search recommendation. That is our main purpose, the recommendation semantic search AI driven analysis for fastest retrieval of the information from the database. So it is a Chrome DB database is a helpful. So so this is what the vector database, which is helpful the embedding model, vector indexing, and here is a Chrome DB storage. It is a vector. This is a vector database. Here we store the data, and what is the purpose? So it is helpful in a semantic search. Uh, so uh, so semantic search is a leverage to vector index to enable advanced context-aware query across all stored data. After this vector database, now our data is ready for the in the format of numeric vectors. So here vector database, you can see this flow structure, uh, process structure data, then we perform the embedding, then this embedding generated this, and then this embedding stored in a vector indexes, and vector indexes are stored in a database, that is here we use a Chrome DB, and then on the basis of we can query on the database, and with the help of the database we can perform the semantic search, and with the help of after the querying we get the query result. And if you want to find the similarity analysis, then we can perform similarity analysis also on the this vector database. Now move to the after. Now our data is ready for the where all data, our data is converted into vectors. Now data is ready for the model automatic AI pipeline. So our automated AI pipeline orchestrate the entire model development life cycle. Feature engineering is automated with the feature tool, while model training with the help like here you can see the model training. Here you going to use scikit-learn library and XGBoost model for the algorithm execution. Then ML flow, here we use to track the experiment, manage the model registry. White Optuna enable hyperparameter tuning. It is a help in the transformer-like model. Optuna it is a help in the hyperparameter tuning. It is a help best way to hyperparameter tuning. And then we evaluate our auto model selection, automate model selection evaluation process, and then model registry. And if required, we perform model versioning also. Suppose one model is not performing very well, so we by the fine tuning, we versioning the model with the help of ML flow registry. So there is a here overall automated AI model development process where we automate the AI ML pipeline. So these are the steps: feature engineering, model training, experiment tracking, hyperparameter tuning, then model evaluation. So these are the steps to be going to be performed in this model automate ML pipeline. The next, and here is this is the overall flow of the our structure. Means what means till the model training, till the model monitoring means flow chart. The next is a insight generation. In this particular phase, after model train, we introduce our insight generation engine, the core of LLM engine. So here we use the this is a Mistral 7B LangChain agent for dynamic query optimization using the SQL database chain enabled structured data analysis. This report are generated using the Jinja template, ensure broad ready format by giving the by giving the query, we generate the text-based insight from the our model with the help of that model, train model, and this insights we can use for the uh, business purposes, getting the insights. So these are the insight generation slide. Here you can see the automated optimization, core aware generation, dynamic templing, confidence scoring, and hybrid reasoning. All these are the insight generation component. After that, this is a flow for insight generation. How we can query the LLM, then insight generate, then here analysis ready data, then structure analysis. After that, uh, LLM query engine insight generated and the report formatting, and then structure insight get uh, we get structured insights. Then after the last step is regarding the deployment of the model. So we want to deploy our model. So after the completion of the model building, deployment is handled through the scalable production grade service like MLflow servings. We can use Docker also to manage endpoint. Here we can use fast API, client SDK in Python. Also we can use. So main purpose here is our model is ready. Now we have to deploy our endpoint. So there is the zero downtime for the deployment. If whenever we want automatic scaling also happening, traffic is more, then automatic scaling also happening. Endpoint versioning integrated with the API documentation and secure communication using TLS, enhanced security. So and here so this is a deployment process. So main key features is zero downtime, automatic scaling, endpoint versioning, and the endpoint versioning, and predictive capacity planning, continuous performing optimization. So and last is this is my workflow for the entire of model deployment. Production system matrix collection, and here you can, with the help of Grafana dashboard, we can build the dashboards that give the insights and root cause analysis, help maintain reliability, predictive capacity planning, and continue performance optimization, ensure the system remain responsive and effective if workload grow also. So these are my presentation on the data analysis agent, and this is the last page regarding my coach information. So here we can visit URL, sir URL. Okay, sir. I completed my presentation.
Good. Rahul, I have some questions. 1 minute. You have 7 phases, right, in this project, right?
Yes.
Planning.
Yes.
Now, if you if somebody asks some client, if you are showing this model is made on the basis of the on-premises environment without cloud. Let us say if they want to implement this model in Azure or AWS, what is the strategy they need to follow?
This we for implementing this model on the Azure. So we can use the there is a predefined services on the Azure, and where we can with the help of the Python script. Also, we can integrate with the Azure, then LLM with the LangChain by we can help with the help of the LangChain also. We can communicate with the Azure. So suppose there we want to, there is a infrastructure setup. So we can get the infrastructure what we want from the Azure storage also, and vector database also present. Azure AI search, there is a vector database also present, and Azure OpenAI service also offering the Mistral 7 BB. And if you want to increase the scalability, then you can use AKS also, Azure Kubernetes service. And for the monitoring here, use Grafana. So there is Azure and log analytics also present. So with the help of that, we can monitor also our model also.
Here
And
you are using ML flow for deployment. Why are you not using Kubeflow? What are the differences between ML flow? What are the disadvantages of ML flow comparatively with Kubeflow or
so
K8?
Kubeflow, Kubeflow, with the help of Kubeflow, we can it is help in the scaling also. Means Azure ML workstation with ML flow integration we can
No,
use.
I'm not talking about Azure ML. I'm talking about this on-premises environment using ML workflow. ML flow is there. You are using it. You
Yes.
have proposed it. You have proposed it. Instead of that, if somebody says, "Why are you not using Kubeflow?"
Okay. Sir, Kubeflow, it is a one type of the we can say the Kubernetes service, Kubeflow. So, but we can use Kubeflow also. But for this but here in this project we are using the ML flow. But Kubeflow also we can use for the scaling purpose.
Yeah, but there are some gaps between ML flow and Kubeflow. You study that for future interviews purpose.
Okay.
Okay. That's all about the questions. Let me stop it.